Hi, thank you for joining us for the Dover Fueling Solutions Innovative and Integrated LNG Fueling Technology LinkedIn Live discussion with DFS Business Development Manager Joost Jansen. To kick things off, Joost, what are the benefits of LNG as a transportation fuel?
Right. Now, first of all, LNG stands for liquefied natural gas. That's the abbreviation. Liquefied natural gas or natural gas is the cleanest of all burning fossil fuels. It's odorless, it's colorless, it's a non-toxic liquid, and furthermore, it's also considered as a very safe fuel. This is due to the fact that natural gas has a very small flammability range, only 5 to 50% air gas mixture. It has a high ignition temperature, and besides, it is lighter than air. So, should it be released in the atmosphere, it's evaporating instantly. And this is also the reason why it's not obliged to position your LNG or CNG dispensers on a liquid tight floor at your station forecourt. Um, yeah, furthermore, I always say LNG is both an ecological but also an economical alternative to diesel in heavy duty and long haul road transportation. Ecological because of the fact that it hardly emits any local air emissions like NOx or particulate matters. And also, even in the fossil LNG, the savings in CO2 can be already up to 20%. Then another benefit I would like to highlight is the fact that LNG powered trucks, monofuel trucks, they pollute 50% less noise, which enables hauliers also to deliver groceries or do the deliveries during the night time, and this avoids them from being into traffic jams that come with daily deliveries. So this is also a very important ecological aspect of running on LNG. Now, and also it's an economical alternative to diesel because of its relative fuel efficiency. Besides, LNG is a fuel. It's not always the case, but it's a clean fuel that is really available today. So there is already an existing network of LNG stations being deployed by segments like the major oil companies, but also by like the regional, national oil companies or dedicated alternative fuel suppliers that have stepped into this new business. And the network is growing and getting denser every day.
And yes, what does the value chain of LNG look like as a transport fuel?
Now, it starts with natural gas, which is being extracted in countries like Qatar, Trinidad, Tobago, but also here in Europe, in Norway. Then it is liquefied natural gas by bringing it down to very cold and low temperatures. To reach, by the way, it also reduces in volume by around 600 times. And you can imagine through this, it's much more effective and efficient to transport this molecule overseas or over the road. After liquefaction step, it's being exported in LNG carriers, maritime carriers, to countries with LNG import terminals. Main reason of these terminals is to regasify the natural gas and inject it in the grid. But also in some of the terminals, and we also see it at the picture here, they have installed truck loading facilities, truck loading bays for the more small scale LNG applications. And then you can think of industry supplies with satellite plants, but also maritime bunkering applications and refueling stations for trucks. That's the fossil route. There is another route. You see that also emerging now, and this is the renewable route for bio-LNG. Now, bio-LNG is being produced more locally, and that's being produced from organic waste, such as sewage sludge, manure, but also vegetable waste. And the process works as such that this organic waste is being digested into raw biogas of around 65% of methane. And then with a biogas upgrading facility, this biogas is purified. So the H2S, but also CO2 is being removed. And then what result is a very clean biomethane. Now, biomethane can be or injected into your grid. We call that green gas. But also, like in more like the large scale facilities, you can also, on a small scale application, liquefy biomethane into bio-LNG. The big plus of bio-LNG is the fact that through this, it's a renewable fuel, and CO2 emissions of up to 100% can be achieved. So really contributing to decarbonization. Now, and then from or the import terminals or from the bioenergy production facilities, the LNG is being transported into road tankers or semi-trailers to eventually the LNG refueling stations where it's discharged into the storage vessels.
And can you go into a bit more detail about what is needed at a service station so it can effectively offer LNG refueling capabilities?
Sure. Now, first of all, I think it's important to notice the fact that contrary to more traditional or conventional fueling systems and installation technology, the fueling technology for LNG refueling system are positioned above ground. So this also needs to be considered during the layout integration stage for your site and for your station. An LNG refueling station requires, first of all, a discharging bay. This is the point where the road tanker is being positioned and it's unloading the LNG into the storage tank. Then, as said, the storage tank needs to be there, and this is typically a double-walled vacuum insulated vessel, and this needs to be properly insulated in order to keep the product very cold conditions. In general, these are positioned vertically, but also horizontal options are there on the market. For example, in the event that there are some height restrictions that arise during the permit application stages. Typically, these tanks are having a capacity between 50 up until 100 cube, so 50,000 to 100,000 liters of storage capacity. Then from that storage vessel, there is a connection to, we call that the pump and conditioning section. And this is the section which is having, among others, a submersible LNG pump, which is bringing the LNG to the right saturated conditions for filling up the trucks at exactly the right saturated conditions and filling them properly. We do that via on-the-fly saturation to keep the conditions inside the tank as cold as possible, meaning that we have low-pressure vaporizers next to the pump skid to bring the LNG to the right saturated conditions on the go. Then from there is underground subterranean insulated piping routed to the LNG fuel dispensers that are positioned at the forecourt of the fuel station. They can also perfectly be integrated next to the dispensers for conventional fuels, but other clean energies. Our dispensers are MID certified to correctly measure the actual LNG dispense quantities. And then the LNG dispensers, they need to be connection to a payment system to ensure that the truck drivers, through their loyalty cards or their payment cards, can release the system, and that invoicing from a service station owner perspective is being managed properly. Should there be a CNG market, then it's also possible to add an LCNG system. CNG stands for compressed natural gas. It's not required to have a pipeline, an underground pipeline for gas in the area of the site, because we can produce that out of the liquid. So in that case, we install an LCNG pump, a high pressure vaporizer, if needed, subject to country legislation, an odorizer to give the alarming smell to the CNG, then high pressure buffers, and downstream the buffers, we route an underground high pressure pipe to the CNG dispenser, which you can also see here at the picture in the presentation slide.
Yeah. And is LNG refueling similar to conventional fuels?
Yeah, refueling of LNG is very similar to diesel, which is the alternative in heavy duty applications, in the sense that we offer a very user friendly experience with our LNG refueling dispensers, but also we offer very high speed refueling at speeds that are also very similar to high speed fueling of diesel at truck stops. I believe the only difference comes from the fact that from a truck driver, so let's say the end user perspective, the operators or truck drivers, they need to be trained on safety and proper operations of the LNG fuel dispensers.
Mm-hmm.
Now, this, among others, results in the use of personal protective equipment, PPE, such as a goggle, but also cryogenic gloves to protect the body from cold temperatures in the very unlikely event of a small spill. So
Mm-hmm.
that is a difference. But again, it's very safe fuel and it's very safe operation. But some precautions need to be taken.
Of course. And can you explain what USPs we offer to the market?
Yeah. First, our systems are designed really to enable the offering and deployment of LNG as a mainstream retail fuel at low total cost of ownership. Systems offer very consistent and reliable fueling performance and experience to the end users. And we do that, for example, via working with the highest safety standards. Obviously, all our systems are ISO 16942,
Mm-hmm.
16943 compliant, but also lots of innovations into our refueling design, such as the vapor return economizers, which are plate heat exchangers that basically serve as heat shields to keep the boil of gas as much as possible out of the heat out of the storage vessels. But also our dispenser standard come with heated purged nozzle docking bay, which prevents from leakages and hence lowers OPEX and also limits the number of exchange of nozzle seals, which also again lowers the number of OPEX. So really, you see, as I started my pitch with already, that our systems are designed to deploy at real low total cost of ownership.
Yeah.
There's another one which I also consider a USP compared to market competition, and that's the fact that we are really not a sell and forget company. So we offer lifetime support with our company in the sense that we have capable engineers, customer support engineers that offer remote performance services for the stations and systems that we deliver to market. And this means that they can do daily checks on alarms and parameters. And also 7 days a week, we offer a second line help desk availability for our customers.
Mm-hmm.
To support them in the event of some challenging malfunctions or whatsoever, which can always occur because LNG, we're really considering and talking about a process plant.
Yeah.
But should there be some challenges or whatever or questions, we are there 7 days a week to help them out. And through this, what we really see is that the uptime and the availability of our systems is really high. We even managed station availability over our full installed base of over 99% during the last year, 12 months in retrospect. So this is something, as a team, obviously, we are really proud of.
Of course.
Yeah.
And Jos, can you explain more about boil of gas and its management? Why is it an important consideration?
Sure. LNG, what I said, it is once liquefied with the benefit that it reduces in volume. Now, storing it in the tanks at an LNG refueling station, basically what is happening is the opposite. So with atmospheric conditions, this gas, the liquid wants to become a gas again, and hence also expands in volume and in pressure. So basically, this is called boil of gas, the continuous evaporation of the LNG in the storage tank causing the pressure in the vessel to rise. Now, the boil of gas needs to be controlled in order to avoid, in the end, venting of methane into the atmosphere. We don't want to do that because, in the end, this is a greenhouse gas. We want to obviously not pollute the environment with that, but also very important from a station owner perspective is, of course, the fact that you want to keep your molecules inside your tank because you paid for that, both in terms of the spot, but also in terms of potential excise duty taxes. You want to keep them inside your tank. Now, we designed our proprietary system, which liquefies the boil of gas on the site automatically. And we do that via our so-called BTU, which stands for Boil of Gas Treatment Unit, which is an automated and plug-and-play system that ensures unlimited shelf life or holding time of LNG inside your tank. And also this, again, is a total cost of ownership friendly solution because it also avoids liquid nitrogen molecules and transport of liquid nitrogen, which is the alternative solution to control your boil-off gas on the site. So really looking into the OPEX, there is significant savings. We also see that at the picture that is shown. And also what we notice is the fact that the bio-LNG, it tends to be discharged in a bit warmer temperatures. Now this system is really capable of controlling back the conditions of bio-LNG into the conditions of the regular fossil deliveries. So yeah, a really sound investment to make, and it's also driven by the market. And also we see much more station owners now going for this solution, not only new to industry sites, but also retrofitted sites that are already there for a couple of years. And that's because of the cost savings. We see also on the picture, in the dark blue bar, they represent the capital expenditures, hence the depreciation and the interest cost on a yearly basis, both for a liquid nitrogen cooling system, which is a traditional BOG cooling method, that's the upper side, and for the BTU. So as you see, the capital expenditures are a bit higher on a yearly basis for the BTU system. But in the end, the TCO savings really come from the lower operational expenditures. A BTU consumes electricity and some small maintenance interventions, and that's it. And if you look at, for example, LIN, which is the upper bar, you see that the OPEX is much higher, again, due to the fact that there are a lot of consumables involved, there's active management involved, and transportation costs involved. So really, this is a generic picture. Obviously also subject to some country-specific costs, for example, for electricity or LIN. But in general, we can say at least a 40% saving in TCO on a yearly basis. And in many cases, it's more can be achieved.
Of course. Well, this has been incredibly insightful. Thank you, Joost. For anyone who's interested in learning more about the LOCAL LNG dispenser or the LOCAL BTU system, in addition to our portfolio of clean energy products, please make sure to visit our stand 5C10 in Hall 5 at Unity Expo from the 14th to the 16th of May. Thank you all for joining.